So let's see a few exercise on the two properties of Laplace transformation that we learned before, which is the linear properties and also the first shift theorem. Okay, so let's solve a few questions here. Let's see the question B. Okay, let's see question B here. So you have 2 sine 4t plus 11 minus t. You have been asked to determine the Laplace transformation of this function. Okay, so now you want to find what is the Laplace transformation of 2 sine 4t plus 11 minus t. Okay, so by the properties of linearity, okay, we can separate all the function here. So what you will have is the Laplace transformation of 2 sine 4t plus with the Laplace transformation of 11 minus with the Laplace transformation of t. Okay, so now if you can see here, you have a constant 2 in front of sine 40, so the constant 2 can bring out from the Laplace transformation process because it's a constant. Therefore what you have here is 2, the Laplace transformation of sine 4t plus with Laplace transformation of 11 minus the Laplace transformation of t to the power of 1. So now we can solve this function, the Laplace transformation of this function, where you have 2. So the Laplace transformation for sine equal to a over s squared plus a squared. Therefore your a here is 4. So what you will have is 4 over s squared plus 16. Okay, plus with the Laplace transformation of 11. So 11 is a constant, so what you will have is 11 over s. Okay, minus with the Laplace transformation of t, where t is a polynomial to the power of 1. Therefore, it will be n factorial, so you have 1 factorial over s1 plus 1, so s to the power of 2. Okay, so now this fraction or this equation can be simplified. It become 8 over s squared plus 16 plus with 11s minus with 1 factorial is equal to 1 s squared. Okay, so this is the solution for question B. Let's see question E. Okay, the longest one here. So let's say question E, we have to find the Laplace transformation of function negative 2 cos square root of 3t plus with 7 delta t plus 1 plus with 4 sine hyperbolic 5t. Okay, so you want to find the Laplace transformation of this function, where this function is a pure function combined with the operation plus here. So what you can do is you can separate each of them. Okay, so what you will have by using properties of linear, okay, you will have the Laplace transformation of negative 2 cos 3t plus with the Laplace transformation of 7 delta t plus 1 plus with the Laplace transformation of 4 sine hyperbolic 5t. Okay, so now you can bring out all the constant out from the Laplace transformation process here. Okay, so you have 3 constant here. What you will have for this equation is negative 2, the Laplace transformation of cos 3t plus 7, the Laplace transformation of delta t plus 1, okay, plus 4, the Laplace transformation of sine hyperbolic 5t. Okay, so now we can solve the Laplace transformation for each function. The first one here, we need to find the Laplace transformation for cos 3t. Okay, so the formula for cos is s over s squared over a squared. Okay, so we have s over s squared plus a squared. So a here is 3 squared Okay, then we plus with 7 and Laplace transformation of delta. So the formula for Laplace transformation for the delta function is exponent negative ds. So now your d is negative 1, okay, because we have t minus d, therefore we have t minus negative 1 here. So your d is negative 1, so what you have for Laplace transformation of delta function here is exponent negative 1s, right? And you have plus 4, the Laplace transformation of sine hyperbolic, therefore the formula is a, so your a is 5 over s squared minus 5 squared, 25. Alright guys, so now we can open the bracket, or we can simplify this equation. So what you will have is negative 2s over s squared plus 3 to the power of 2 is 3, okay, plus with 7 exponent negative s plus with 20 over s squared minus 25. So this is the solution. Okay, so it's easy by using the first property, which is the linear properties. Okay, let's see one more example here. Let's say we want to solve the question H. Okay, question H. So we have here a function 3t to the power of 4 minus with 7 delta t minus 4 plus with sine hyperbolic 11t, right? So now let's use the same properties, which is the linear properties. So what we will have here is the Laplace transformation of 3t to the power of 4 minus with the Laplace transformation of 7 delta t minus 4, okay, plus with the Laplace transformation of sine hyperbolic 11t. Okay guys, so now we can bring out the constant 3 here, the constant 7 here, and also, okay, there's no constant there. Okay, so what you will have for this one is 3 Laplace transformation of t to the power of 4 minus with 7 the Laplace transformation of delta t minus 4, and also plus with the Laplace transformation of sine hyperbolic 11t. Alright, so what you will have here, you can solve already the Laplace transformation. So for this one, you need to find the Laplace transformation for the polynomial t to the power of 4. So the formula is n factorial over s n plus 1. Therefore, you will have 4 factorial here over s. 4 plus 1 is equal to 5. Okay, minus with 7. The Laplace transformation for delta again is exponent negative ds. Therefore, your your d here is 4. Okay, so what you will have is exponent negative 4s. Okay, plus with the Laplace transformation for sine hyperbolic, where the formula for sine hyperbolic is a over s square minus a square. So your a here is 11. Therefore, you will have 11 over s square minus 11 square. Alright guys, so now let's solve this equation. We have 4 factorial here, where 4 factorial is equal to 24. Okay, then 24 times with 24 times with 3, you will have 72. Therefore, you have 72 over s to the power of 5 minus with 7 exponent negative 4s plus with 11 over s square minus 1 to 1. Okay, so this is the solution. Let's solve a few exercises related to the second property that we learned, which is the first shift theorem. But first of all, what first shift theorem tells you? Okay, first shift theorems is about how to find the Laplace transformation of the function of ft, where ft involves the combination of exponent function with any function ft. Okay, when you have this combination of function where you have a function times with exponent function here, you can solve, or you can find the Laplace transformation of the ft, okay, by using the first shift theorem, where first shift theorem tells us that to find the Laplace transformation of ft, what you will have here is f s minus a. Okay, what does this mean by fs minus a? Okay, the first thing you need to do is you need to find what is the Laplace transformation of this function first. Okay, then you need to know what is the value of a. Okay, then you need to plus with negative a at each s in the Laplace transformation. Okay, so let's see one example here, one exercise here. Okay, so we have the first one, a exponent negative t cos 40. So the first thing that you need to recognize it, what is the function ft other than exponent function. Therefore you have ft equal to cos 40 here. So let's write our ft. So our ft is equal to cos 40. The second information that you need to know is the value of a. Okay, so the value of a comes from the exponential function here. Therefore here is the value of a equal to negative 1. So let's write down the value of a is equal to negative 1. Now we want to find the Laplace transformation of this combination function by using first shift theorem. So the first thing you need to do is to find the Laplace transformation for ft. Therefore you will have fs. Okay, Laplace transformation for cos is s over s squared plus 4 squared is equal to 16. Okay, now because this is the combination of exponential function and the function ft, therefore our fs is equal to our fs minus a. Now our a is negative 1, therefore we will have fs minus negative 1. Okay, so what you will have here is fs plus 1. So what is the meaning of fs plus 1 is, for every s you need to write plus 1 beside the s. So what you will have for your final solution, if fs plus 1 is equal to s plus 1, every s you need to replace by s plus 1 over with s plus 1 square plus 16. So this is the solution. Let's look at the second question here, question C, okay, where you have the function exponent 3t sine hyperbolic 16. Okay, so if you see here, you can see two functions. The first function ft times with the second function, which is the exponential function. Therefore, to find the Laplace transformation for this function, you can use the first shift theorem, where the first thing you need to know when you want to use the first shift theorem is what is your ft. So your ft is the function other than the exponential function. Therefore, you have your ft equal to sine hyperbolic 60. Okay, the second information that you need to know is what your value of a. Okay, the value of a comes from the exponential function here. So here your a is equal to 3. Therefore, you have a is equal to 3. Okay, so you want to use the first shift theorem. So the first thing you need to find what is the fs, the Laplace transformation of the function ft here. Therefore, we have the Laplace transformation for sine hyperbolic is equal to a over s squared minus a squared. So your a here is 6 divided by s squared minus with 6 squared is equal to 36. Okay, now because of we want to use the first shift theorem to find the Laplace theorem of the whole function here, therefore we want to find what is our fs minus a, and here a is equal to 3. Therefore we want to find what is fs minus 3. Okay, how to find fs minus 3 is very easy. You just need to replace all s in your fs with s minus 3. Therefore you will have 6 over x minus 3 to the power of 2 minus 36. This is the solution. Okay class, so let's do one more exercise here by using the first shift theorem. Let's see the one B here, the question B here. Okay, so the question B, we have sine 70 over exponent 50. Don't be panicked when you see this fraction, because you can bring up the exponent 5t here. So what will happen, the power of exponent will be negative. So if you rewrite this function, you will have the exponent negative 5t sine 70. Okay, so now you can see the combination of two functions. The first one is exponent negative 5t, and the second one is sine 70. Okay, so here, because this is the combination of ft and exponent, so we can use the first shift theorem. So to use the first shift theorem, the first thing you need to know is what your ft. Okay, your ft, other than an exponential function, your ft is equal to sine 70. The second information you need to know is what is the value of a. So now the value of a comes from the exponential function here. So the value of a is equal to negative 5. Okay. Okay. Next step is to find the Laplace transformation of ft. So you have ft equal to sine 70. Therefore, your fs is equal to, the formula for sine is a over s squared plus e squared. So your a here is 7. So a equal to 7 over s squared plus 7 squared is 49. Okay, now by using the first shift theorem, you need to find what is fs minus a, and your value of a is equal to negative 5. Therefore, you need to find what is the value of fs minus negative 5, okay, which is fs plus 5. So how to find fs plus 5 is very easy. You need to replace all s in the function fs here with s plus 5. So what you will have fs plus 5 is equal to 7 over s plus 5 square plus 49. So this is the solution of the Laplace transformation by using first shift theorem.